Okay, so here in alkanes, chemical reactions of alkanes, what we are talking about, we are talking about cracking, which is actually a thermal decomposition. Thermal decomposition, what does it mean? Thermal means heat. High temperature is required when we are talking about cracking. Now, let's write the definition of it. What is that? High temperature is required for what? Thermal decomposition. Thermal decomposition of what? Thermal decomposition of large chain of alkanes, of large chain of alkanes into what? Into smaller alkanes, into smaller alkanes, or even alkenes. This is what, we will be talking about. Now, how will it be done? Here, mainly, we will be talking about reaction conditions. What reaction conditions are required to do this? So as you know, the name says, and we are talking about reaction conditions, we will be talking about higher temperature, right? That is very important. So about 400 to 800 degrees Celsius. Temperature that will be required is from 450 to 800 degree Celsius. This is the temperature. Then we will talk about catalyst as well. Catalyst, yeah. Which catalyst is required? Alumina. Alumina, which is actually what? Aluminium oxide. Okay, aluminium oxide. What is the formula of aluminium oxide? Al2O3. Alumina. Other than that, what we can talk about? We can talk about silicon 4 oxide. Silicon 4 oxide, which is also called silicon dioxide, SiO2. Yes, so these are the reaction conditions. Now let's talk about the example of it. Let's do the example. In the first example, of course, we will be writing a few examples to understand it better. The first example that I give you, it is about this. What do we have? We have decane. Okay, right here, I think that we have decane. And decane, it is gonna be decomposed into what? Okay, easier way to write it. Let's say if I have given you 3 of the products which will be made from here. So how you gonna do that? First, what you do is write the formula of decane. So decane is what? C10H22. Okay, so when I do this, it means my products, they must be C10. So what I do, I can try doing what? C5, 5, 3, and 2. 5, 3, and 2 means it has already given me 10 Cs, right? Then you know what I do accordingly. Hydrogen also C5H12, right? C3H6 and C2H4. Now count also 12, 6 and 4, 22. So means I have equal number of carbon and hydrogen. Now let's write their name, what I have got. C5H12 that I have got, and then right, then next what I have got, C3H6 is propene, and C2H4 is what it is? Ethene. So this is how we write the examples of thermal decomposition, where large alkanes are decomposed, broken down into smaller alkanes and alkenes. Here we see another example of it. Yes, no name, which is C9. Yeah, correct. And here we have decomposed into 3, 2, and 4. Means 9 of them. Propane, ethene, and butene. Correct. And here we have octane, C8H18, and decompose into ethane, ethene, and butene. Correct. Okay. Now, we will go further in this thermal decomposition. Here, we have taken the example of where, these larger alkanes, they are decomposed into smaller alkanes and alkenes. There is also one more reaction in it. Let me name it when, I'm talking about cracking. We are still talking about cracking, right? Yeah. Thermal decomposition. One more reaction means what other products could be formed. So let me name it reaction number 2 when I am talking about it. So reaction number 2, here we will talk about it, that hydrogen. Here, hydrogen will be produced. So hydrogen can also be produced by cracking. So here, when we are talking about that, it can also be produced. How, what is the equation? Yes, as we always learn by equation in chemistry, we should know. So ethane will be decomposed into what? Into ethene plus hydrogen. Okay, so what will be the equation when we are talking about it? Ethane is what? C2H6, and it will be decomposed into C2H4 ethene plus hydrogen H2. Yeah. So this is how what we will remember, another reaction for cracking where hydrogen will also be produced. Here we have the reaction. Let's, write one more example of it. For example, I gave you butane. So butane is going to be decomposed into what? Butene as hydrogen. Okay, so let's write the equation for that butane, which is C4H10, and it will be decomposed into C4H8 butene plus hydrogen. Also, since we have already discussed about the thermal decomposition, the reaction of it, the cracking. Okay, also it is important to know that, why is this so? Why do we need to decompose these larger chain alkanes? Because these larger chain alkanes in the gas, oil, or kerosene fractions, they are less useful. That's why they are broken down into shorter chain hydrocarbons, which are actually more useful, right? Yeah. So here, we can talk about it. Let me write it here. It would be better, like, whatever we are talking about, like, why is this so importance of cracking? Or you can say thermal decomposition. Why is this so? Why we are doing that? This is because larger chain, or you can say longer chain, right? Larger chain, or you can say longer chain alkanes in the gas, oil, or in the gas, oil, or kerosene fraction are less useful. Fractions are less useful. So broken down means thermally cracked, broken down into smaller chains to make them more useful. What does it mean? Okay, here, let's talk about it. For example, where they will be more useful. Okay, shorter chain alkanes are used for petrol. Okay, and some are used for fuel. Okay, LPG, shorter chain, I write here, shorter chain alkanes are used for petrol, some used for fuel, liquid petroleum gases, which is commonly used as LPG, liquid petroleum gases, which is commonly known as LPG. Yeah, so this is what we will remember. Also, alkanes can be used to make a variety of chemicals. Okay, alkanes, shorter ones, right, can be used to make variety of chemicals, such as what? Such as plastics. So this is also the example that we will give. And also then, hydrogen is also formed, which can be used for making ammonia, right? In the reaction. Hydrogen can be formed, which is used to make ammonia, right? So these are the ones. Hydrogen, it can even be used or as a fuel, it can be used. So you see, like, there are many of the uses which can be attained from these longer chain alkanes into shorter ones. Let me put them here, and these are the uses.